Greetings, everybody. A very warm welcome to Kaizen Central. It's sunny on the south coast of England Thursday evening. I do appreciate everybody coming along. I know this is probably the last thing we shall do this week, pre the Easter break. Can you imagine 4 days off? How is everybody? Assuming thumbs up? Thumbs up, looking for it all? Okay. Stephen Barr, lovely to see you again. And I'm now trying to trace, there he is, Iain Crosley. A very warm welcome to you. Terrific to see you. There. I'm going to get cracking because we've got a lot to talk about. I asked Iain to join us. Hands up anybody who knows Iain from when he was at Hosokawa Micron. Yeah, some old friends. Yeah. Last time I saw Iain, we were having dinner at some presentation in Birmingham. Who was the speaker that day? Brian Holiday from Siemens. Yeah, haven't seen him for a long time. And Iain and I had a great time that evening. And then, sort of, I didn't lose track of him, but I lost sight of him. And up he pops. He's got this wonderful new company that he's working with, XpertRule. And we're going to talk a little bit about that. But it's really about AI. XpertRule are a very, very experienced company when it comes to artificial intelligence and software and all of that. But they haven't really done more than just dabble in the world of manufacturing. Not bad dabbling. Diageo did a lot of brewing and distilling work, but Iain's here. We could talk about what they'll be doing at XpertRule with their manufacturing software. But I really wanted him along because as soon as I hear AI, my eyes start to glaze over. I think there's an awful lot of mythology about AI whipped up by people like myself, journalists, in the media who frankly, I don't know, they talk about AI, they talk about robots, they talk about everybody losing their jobs, et cetera, et cetera. And I wanted Iain to come along and just do a bit of demystification for those who need it. I'm sure that there are many experts in amongst us who will already understand exactly what it's all about. But Iain, I'm going to hand over to you. He's got a short presentation, but the idea is for us all to have a conversation, swap some ideas, give him some information that will help him in the course of their the launch of their new product in April. Iain, over to you. Welcome.
Okay, thank you. So thank you for the introduction, Nick, and for the invitation to talk to you guys about AI. What I'm trying to do is do this as agnostically as I can and talk in general terms. So I'm not really going to talk about technology or go into any great depth, but more give you a feel for the type of things we can do, the kind of areas that we can work in manufacturing particularly. Just a little bit of background, I also work in areas outside of this. So my daytime job is with XpertRule, and you can see my contact details at the bottom here, so feel free to talk to me if you have any questions outside of this and do it. But I'm also involved with the University of Lancaster in helping them come up with their research strategy. And we're looking at different pillars where AI is also being used. And these are things like future mobility, forensics, medical devices, medicines, and even things like predicting when cholera and Legionella occur. So very wide ranging beyond what we do. So there's a lot of topics out there and a lot of things where this is being used. But I want to start off really by coming back to something very, very basically, and I'm doing this the first time here, but I'm talking about our mobile phones. And if you take our mobile phones, it's much more than a phone now. When I first started in this field, the compute power on a mobile phone now is much more than desktop computers were at the time. So the capability we have on these phones is incredible. And if you take the phone here and you see, you've got your photographs on it, I've got my business notes, I've got access to all the information I need around my business, I've got my music, I've got my emails, I've got social communication, I've got my organization, and I've got the different communication media that we're using here, all on that. But there's a big difference between us and the way we use these and some of the young generations. So typically, if people want to know things now, they expect the answer straight away. So they will talk to the phone and ask them a question and get an answer from something like Wikipedia. Well, the issue with Wikipedia is people have put information there, but it's not necessarily absolutely factual. It may be approximate. But the point is people rely on that as a source of information now. So the first thing they're doing is they're actually talking to their phones and getting information from them. So the next thing I'm going to bring up is a picture of my beautiful dog here, Steffi. And Steffi likes to have a photograph taken and be recognized and be shown to people and be talked about. Now, when you take a photograph, you actually get a lot of data around this photograph. So I'm showing some of the data here. So what we actually get is auto-generation of an ID of this, an ID of where we are. We get details here around the machine. So this is the camera, how it's taken this, and the data it's used, and the settings it's used. You get the location information. So you're starting to get a lot of information around applications here, and some of that is auto-generated and auto-recognized. My life's a little bit complicated, so I've got a second dog, which just also happens to be a German Shepherd. And if I want to find out and search for their information on my phone, I can go in and search for it, but it comes up as really only looking for information for dogs, which gives everyone. So if I want to specifically look at these, I have to name the dogs and tag them. So a human intervention in this process. So I'd have to name it as Steffi or as Yoshi before we can start to get it. Otherwise, we're set with set searches, which would be dogs, chipping, England, Scotland, whatever else, and do it. So if we really want to get the most out of systems, we actually have to manage the data that goes into those systems. And to make things a little bit more complex, I also have twin boys. So if I wanted the twin boys to interact with those systems and identify them, I've got to be able to get a means of identifying in that system. Well, again, on your phone, you can do this. You have biometrics. So here you could do retinal recognition or fingerprint recognition. So where are we? We're looking at AI technologies here. So we've actually seen there visual perception, neural networks being used, NLP, such as natural language processing. We've been using a small amount of machine learning and deep learning there for the algorithms that have given those search engines. And there's also some expert systems in there. So on a very simple device, we have actually seen a whole range of AI technologies deployed, and people don't think about that. So these are what they call narrow or weak AI. So these are very simple deployments. But when we start to look at what we're trying to do in engineering fields and manufacturing fields, we're looking more at AGI, which is artificial general intelligence, which is applied across a wider area. And this is much more interconnected systems and interconnected devices. So the AI is working across a number of application areas. But in definition, AI is the name given to a collection of programming and computing techniques that attempt to simulate and in many cases exceed aspects of human level perception, learning and analysis. So it's very... So just something here that's a little bit of interest to everybody was in 2017, the government stated that it wanted the UK to become a leading centre of excellence in AI. And it highlights a number of areas where we needed to work with this. So it's increasing access to data and the ethical use of it, maximising AI research to improve the supply of skills needed for jobs for the future and support the uptake of AI to boost productivity. At the moment, apart from very large companies, AI in major industrial applications is relatively low. So I guess my question is, where was the government and what are they doing to help us in this? So the next area I'd like to talk about, and it's just to set the scene of where we're going with our businesses, is to talk about the difference between digitalization, and digital transformation. So I would define digitization as basically doing the same as we've done, but taking it from an analog world into a digital world. So here, typically taking something, for example, like a record and converting that signal from an analog signal into a CD where you get digital. The progression of that is to add in a compute device. So here we've taken lots of digital inputs, we've collected them onto a device. That device has got some intelligence in it, so we can actually sort our songs by playlists, by type, so genre or anything else. But we can also take that anywhere and use it easily. We're not carrying lots and lots of CDs with us and having to change the play of it. So what we've actually done is miniaturized the system and actually been able to move it. But when we talk about digital transformation, we talk about consuming and using our music in a different way. So what we're doing here is we're actually paying per play or paying per use and doing it. So we've actually changed the business model, the model by which music's sold, music's produced and done. And this is what we're doing in our businesses, and this is what we're trying to do. And it's very important when we start to look at these technologies and how we do it, is what are we actually trying to achieve here? Are we trying to get a digital transformation for maybe moving from providing a product to providing a service, or are we just giving better clarity of what we're trying to achieve? So it's very, very important we do this, and this helps a little bit define what we can do and what we can't do. If we start to look at the factory environments, we can really divide it into 3 areas. So the first way is the way that we actually bring products to life. So here we're looking at things like generative design and iterative design and building intelligent models. So these can be reused and do it. So in generative design, we're putting constraints in so humans know what they can and can't do in the design. With the application of AI, we can apply those constraints to those design processes and build them in place. And by connecting the two together, so the generative design and the intelligent models, we can come up with a system which gives us a very deep learning and understanding of those processes. In addition to that, we're changing the way that products are made. So here we're applying new types of techniques, so additive, subtractive manufacturing. We're actually looking at the automation system so we can give feedback into these, and we're also aiding that process by bringing in robotics. And then the products and the way they're being used. More and more products are getting connectivity, they're getting intelligence, they're getting data driven from these, and this it can be connected through cloud or other means back to the start process. So we can actually get an iterative process where the product is actually talking back to the design process. So we've actually got feedback all the time, and we can actually improve the products by that system. So again, this is changing the way we think and the way we manufacture. Just the last thing I'd like to say really before we go into a bit more depth on this is you need to consider how and what you're trying to do. Are you in an existing facility, so a brownfield site, or are you starting from greenfield? And the considerations here are very, very different. With greenfield, you've got the ability to design from scratch, start from a clean piece of paper and build it in. When you're talking about brownfield, it's very much, you actually have to run the business while you're doing it. So whatever you do doesn't want to be disruptive. It wants to be able to be done while you're in the business, delivering your customers' expectations, delivering your sustainability and your profits. And this is why it's important to align the business strategies to project strategies. So it's just how complex these solutions are and how difficult you make it, and the risk in there is just a consideration in here. So when we start to look at that, I think we'll all be familiar with typically these common challenges. These are the same across whatever manufacturing sector we're in. And these are typical things that we want to address by improving the process. Now, the first start point here is whatever technologies we use, we actually have to have systems that work well. We can't have badly behaving systems. If we do, all we do is get data from badly behaving systems, which doesn't help us. But the bigger approach is, if using AI, you can start to understand the process. So by setting KPIs for that process and learning about the data that's in there, you can build multi-dimensional data models which start to make sense and are validatable. The next thing from that is you need to start to monitor those systems so you can actually see what's happening in real time, what's happening against other changes you make to that system and how you do it. And the final way you can do it is to get control. So what effectively we're doing here is understanding what is good, what is bad, understand the differentiation on them, also understanding how we can get from that bad operation to the good operation and maintain it. So typically here we're talking about where we see shift to shift variation, because each shift operates a plant differently. We can operate in the good zone across all shifts and let the people get on with what they're doing. In other words, producing goods rather than making process changes. So where can we apply intelligent process automation, AI and IA, and they interlink here in two ones? So the first area is the front office scene. So this is where we engage with our customers, how we engage with those customers and the information they give us. So this helps us with our planning, how we can give information to our workers, our partners, and how we can build systems to help people do that. So that's the first area we can work within that. The second area is capturing intelligence, so capturing knowledge. This is very, very important, where a lot of companies are losing people through retirement, they're losing expertise through that. And you can actually capture that human knowledge and bring it into the process as well. So it's not just from data, it's actually human knowledge you're bringing in. The next area we're looking at is how we actually work in the production environment, how we connect on the shop floor, how we can influence the decisions, the predictions and the processes, and how we can improve all those. So the distinct operations in each of these where we can add it. And then the back office. In the back office, we have a lot of repetitive tasks. So typically here, we can be producing documentation for quality, compliance, etc., and do it. And there's a lot of techniques that automate that. So things here like robotic process automation, but basically it takes huge volumes of data, basically screen scrapes it and brings it back. But we can add intelligence behind that, so we can actually simulate what a human being would need to generate a report. So in a factory, you can use AI in all of the areas of the business, but it's choosing the right AI and choosing where it's beneficial. And it's normally beneficial where people are doing repetitive tasks and making mistakes, or doing very complex tasks, which they don't do regularly. So this is a little bit now I want to talk about deployment of AI and how AI is deployed in an industrial environment. And this bit here, this unified low-code platform is what's really important here. A lot of AI solutions use a lot of compute power. And when you deploy a solution for it, because of that compute power, it makes the technology slow in its reaction to systems. And the key here is you need an open integration to the AI or machine learning services, where you're getting your data from, how you're processing data, and how you're deploying your applications. So these applications are a list here of what you can do. But what we're saying is these should be in a very low code environment. So what do I mean by a low code environment? It's not a scripted environment. It's not a software driven one. It's one that engineers or manufacturers develop by dragging and dropping code in there. And that means that it can run on low power compute devices. So typically an analytics engine should be able to run on something as simple as your mobile phone or a Raspberry Pi. It shouldn't be running on high level compute systems. So it's quite important to understand this low code, no code environment and the way that systems are deployed. For me, the big area where we get advantages is really moving from a linear economy to a circular economy, and understanding how you do that and where you do it, where the advantages are. One of the big areas for AI is here in the raw materials. So looking at formulations and looking at how the product's made, what's made in that product, and how those materials are then changed in this use period. What happens? Are those products actually able to be recyclable? So have they been exposed to extreme pressure, extreme temperature, something else which doesn't make it recyclable? So understanding this, and this is the connected product coming back in, where it can be used to define its use and its capability and availability. And for me, this net zero sustainability is one of the huge drivers we need here. So in terms of what are we trying to do here? Well, we're doing two things. We're using systems engineering, and we're looking at how we connect sensors, actuators, control systems, and how they interact with people. So there's two bits here from process system engineering background. From a background of business, I've always been using this in my business methodology, which is plan, do, check, adjust. So this is a system where you use manually in a business, and adapting that to an AI one, it's this monitor, assess, act. And what we're doing here is automating all those processes. So we're detecting suboptimal performances and faults, diagnosing and predicting issues, assessing risks, checking compliance, providing troubleshooting environments, looking at how we can improve performance, so process advisory, and also running optimization and control algorithms within that as well. So what's my view and how do you go about this? So a lot of people offer a view where they go across the whole operation. And my view is you can't do that, because if you're just using software to generate this, and typically using data scientists, they will give you answers, but the answers are not employable. So if we take a typical operation where you've got formulation, you've got the process, you've got packaging, you've got distribution, you've got quality, and an overall operation, each of those has different expertise and different needs in it. So if we take the process bot, we need somebody with deep domain expertise to really get the most out of this. Because at the end of the day, AI is software and it's got to be educated and trained to work well. So it needs that information and that understanding. If you don't create it correctly, it will not work properly. So when I talk about a process bot, what do I mean? I mean somebody who's an expert process engineer. That process engineer is consistent 24 hours a day, 7 days a week. He doesn't have holidays. He doesn't have heavy nights out, and he doesn't get ill. So he's making a consistent decision all the time. So you have to build these understanding and these bots around every bit of the business and then look to connect them. If you try to put a holistic approach across it, take all the data and find outcomes and desirables for it, it will not be accurate and it won't be understandable. And the other thing in each of these is where they're rules driven and decision driven, you need to be able to understand where they're coming from and is this the right way to do it, because you need to validate it. So what I'm saying in here is, even with AI, don't forget the human. The human's important. Don't necessarily rely on people who are computer scientists, because they don't have the domain knowledge to come up with that, and they'll come up with statistically the right answer. But there are huge advantages in using them. And it also helps get human beings to do the things that human beings are best at. So you can take away the boring tasks or the difficult tasks. So overall, what would I say the benefits are in here? So first of all, it's net zero. Next one's availability, competitive advantage in customer experience, the ability to plan and to use your assets to maximum capability. Obviously, there's a cost driver in here, and this can be around energy, about materials, material usage. Quality is a huge one, really driving towards net zero defects, but also having an auditable process, which is auto-generated. And the final one is capacity generation. This is by enabling people and giving people better jobs, getting people to do what they want, and also giving them a better work-life balance. So that's a whistle-stop view through AI. It's really a sort of subjective one. I've been agnostic to technologies that are used in here, hopefully, but I've tried to relate it back as easily as I can to how it can be deployed and used.
Well, Iain, thank you very much indeed. I learned a huge amount from that. Thank you very much indeed. So the floor is, as always, yours to talk to Iain about some of the things he's been talking about. And I'm just wondering if that description or that overview, that whistle-stop tour, has given you a bit more understanding about AI, because I think the one thing, when Iain and I were chatting the other day, to me, it was just capturing the human knowledge and sort of feeding it into the system in such a way that it's replicable. And Iain, I'm going to ask the first question. Can you just tell us what you mean about capturing that human knowledge and feeding it into the machine? How is it actually done?
Okay, so well, there's several ways of doing it, but it depends what you're trying to do. But I suppose a very simple way of looking at this is, if you took a call center operation and you phone up to get your broadband problems troubleshooted, the person on the end of the phone doesn't have that expertise, but they have a process flow that they're following through from an expert in that. So the first thing they will ask you a question is, has your router got a red light on it or a green light? if it's got a red light, has it got this on it? If it's got that on it, has it got that on it? And that has been captured by talking to somebody who can describe that as a process flow. So they describe to somebody a fault and what are the indications of those faults and what do you need to do. So effectively, the first way of doing that is to capture that information and do it and put it into a flow. So if the question is this and the answer is that, where do I go? If that's the answer, what's the next question? So it's built up by really talking to somebody with that deep knowledge and building up a process flow from them.
Okay, and I guess I talked about the way that the media describe AI as eventually machines learning so much they're going to learn how to replicate themselves and we'll all be out of a job, and worse yet, we'll all be dead. The grey goose syndrome, I think they call it. The fact of the matter is that the machines can only be as intelligent as what goes into them. Is that right? I mean, the AI can only be as intelligent as what we tell it to be, or can it really start to generate better decisions than we can?
Okay, so it depends on the method that the AI has been deployed in and what the AI technology is. But effectively, AI is working against set outcomes against set attributes. So if the attributes don't change and the outcomes don't change, the AI doesn't change. Where people start to talk about AI taking over is where I've talked about AGI. And this is where you can start to interact with other things. So normally AI doesn't react with the outside world, it only reacts with its own environment. But AGI can react with the outside world. And when you get into that, yes, it can go open. But the way you stop it doing that is it's a bit like your cruise control on the car. You only allow it to do that within certain bounds. So in other words, in a car, you set your speed. If you touch your brake or your accelerator, the AI comes off. And it can only do that within certain range of operation. And that's exactly the same as you do to safeguard it.
Okay. Who's got some thoughts to share, either observations? Stephen, good evening to you. Lovely to see you.
You too. Iain, thank you for reminding us that the government once had an industrial strategy. We're still waiting for the AI revolution as a result of that. I was fascinated, you're talking about a holistic approach across the business won't work. So a progressive approach sounds like the way forward. I wonder if can you spot one place where the revolution will start in AI, and maybe that's something we can all get chipping away at.
Oh, I mean, to me, one of the places it can really work and being a big advantage is when we start to look at emissions, especially in heavy energy using industries, and understanding all those interactions of how we adjust that. And with those processes, there's quite a big latency normally between making a control change and actually seeing something that you can measure on the output of it. So if you can start to model that using AI and predict that on a multidimensional scale, that would be huge. And I think that's a big part of us achieving our net zero goals.
I'd love to talk to you in more detail about that. I think that's a big area, definitely.
Anybody else got any thoughts or questions, statements, observations? Niraj, good evening to you.
Hi, good evening, and thank you, Iain. That was a very, very interesting presentation. And fact is, most of the people, we all know that digital transformation innovation is the way to go. But what I've seen is that people generally know how to go about it. So they know it's good, but how to go about it is a challenge. And essentially, what I've seen is it's all about mindset, tool set, and skill set. The challenge I've seen is around the mindset. People are not able to build that mindset for transformation. So I want to check with you, in your experience, which has been the biggest challenge you face in your digital transformation, the stuff that you do?
People, without doubt. Getting people to change their mindset. And I know Stephen's here and he knows Stephen Barney knows some of the challenges I've had in my career around this. And it is very difficult to get people to change. And I think there's two reasons for that. Is people like siloed information. If I've got my bit of information, I protect my bit of information, I've got value. So that's one part to it. And the second part is people tend to think that data is valuable, so they don't want to share data with other people. And all of these exercises around collaboration. You've got to work with other people to get these results. You won't do it on your own. You know, nobody's got that skill set really to do it, or very few people. So breaking down these barriers about knowledge is mine, knowledge is value, and then the fact that I don't want to share anything with anybody else, and I don't want to say to somebody, I don't know how to do something. Those are the barriers. So the people thing is difficult. I think there's been quite a bit done to educate people around this now. And I know sort of on the Made Smarter campaign, they've actually run an education process, which has put lots of people in the same room together, going through the same experience, and they've started to collaborate together. So it's teaching those things. I know Stephen's been doing similar things as well, trying to get people to collaborate and understand how these things work. So I think things will change, but it is difficult to get people to accept the benefits.
Yes, people won't change, just change the people. I mean, that's the old-fashioned way of looking at it, but not sure that works today.
Unfortunately, there's HR lawyers out there.
Damn them. Anybody else who's got some thoughts? Yeah, Simon, good evening from Washington, D.C., or good afternoon as it is there.
Good afternoon. Yeah, fascinating. Thanks, Ian. As a number of other people know, I work mainly in healthcare, but in data analytics. And we've seen some really substantial changes in some key areas as a result of the application of AI in its broadest definition. A lot of it's machine learning, but let's use the broad definition. One area that I find particularly interesting is the way in which university research has turned into commercial applications of AI. The university environment being perfect for someone to say, that would be a great application. Let's try it. And so it becomes a PhD paper, or becomes a project in an academic environment that then turns into a commercial application. The one I'm thinking of particularly is in market research. There's a lot of market research that's done that is, it's called qualitative, where you're having a discussion with usually a subject matter expert about a particular area of interest. And what they did was to use some really quite clever deep learning techniques to predict the nature of the individual's response so that the AI could rephrase the next question so as to increase the likelihood of a beneficial response. And the beneficial response is not necessarily the right answer. It's an answer that will add to the value of the conversation. And that is beginning to significantly change people's minds within the market research world about the use of AI in a way that they wouldn't have done had that basic research not been done at the university level.
Yeah, you're right, Simon. There's quite a lot done there, but it's actually a growing area, which is conversational AI. So it's recognizing people's characteristics from answers to questions, because obviously they can't sense emotion.
Talking of university, I mean, Nanopore is the sort of the business story. We're all expecting Nanopore to go public. That was the genome sequencing offshoot, was it Oxford University? Somebody knows better than me, perhaps. And their capitalization is going to go through the roof, and they're going to go public later on this year. That's one of those sort of COVID stories. But again, that was out of university. So any thoughts about AI and what Ian's been talking about? Who'd like to ask a question? Dive in. One thing I'd like to ask Paul. Oh, sorry, Bram, go for it. I'll come back to you in a second, Paul.
Thank you. Thanks, Nick. Ian, that was fantastic. Thank you for the presentation. My question specifically is, we're talking about AI and how the whole artificial intelligence and automation is going to change our lives for good. But all of these things, there is a certain degree of time scale involved. And can you realistically give us some kind of a finger in the wind estimate as to what time scale are we looking at before we can completely trust AI to do the job under many changing situations? while we sit down and have a comfortable cup of tea or have a Kaizen Central, and the AI is doing what it is doing despite changing dynamic conditions everywhere, like what's going on right now?
Yeah, I think it depends on the complexity of what you're applying it to, is the first thing. I think for relatively straightforward processes, which maybe have something like, I don't know, 30 to 70 inputs and outputs to them, that's here now. That can be done, and it can be done quite reliably. But so long as it's done in the way that I said, it's a cruise control, and if it stops, it fails safe. I think getting to the next stage where something can run itself, adjust itself, control itself as a closed loop control is probably in the next 5 to 6 years that will be possible. But I think going beyond that, it's all the technology changes that are happening are going to influence that. And if you think how fast compute power develops, how fast intelligent other ways deploys, those are going to be accelerators of it. And some of the work that's been seen now has been done is using 5G, and suddenly the amounts of data you can suddenly shift and move reliably has changed it. So that whole market will change with time, but I think you will see a lot of deployments over the next 5 years, and I think that is where the uptake will be.
Can I just add one point to that?
Sure.
The amount of data and the processing capacity of computers is obviously a key issue here. And I think it's very interesting that some of the most advanced computer companies in the AI world are actually the people that make the graphics cards. Because graphics cards usually have somewhere in the order of 500, 600, 700 processors, which makes them perfectly suited for massive amounts of parallel processing. And this is already changing computing in AI quite substantially.
Yeah, Robert, Bob, good evening.
Can I just ask a question, because you're talking about AI and it's kind of use, you could put it to use in the green world, managing the ecology and so forth. With all the data that's being churned and the data centers that be set up to support that, which take huge amounts of energy to cool them, I don't understand all the green impact of that, but it seems to me that there is a huge amount of energy managing the data through data centers and so on. So the more data we use, the more energy we use. I have no idea what the economics of that are. Does anybody?
Oh, I can't answer that straight away, but the point is absolutely correct. I mean, the cloud is just remote computing power, and computing power is energy power. So I suppose the answer is the more efficient computers become, the lower that becomes. But I think the point here is, and I'm going to be a bit controversial here, a lot of big providers of data analytics say just get every bit of data you possibly can and it will give you the answer. So just get more and more and more and more data, have more and more sensors, and it will give you the answer. The reality is you don't need all that data. You need specific bits of data to answer the questions. So it's probably rationalizing the data would make it greener, if you like. So there's two sides to that. At the moment, people are just saying take data. They get these data lakes. My opinion is you just drown in a data lake. What you're looking for, it's a needle in a haystack. You're much better coming from a structured approach of understanding what data influences the outcome you're trying to look for, what potentially additional data you may need to get to that decision. So I think it's designing the data to fit the outcome is the answer to it in a green world.
And is that a discipline that you're aware of, that it's being applied systemically?
At the moment, no. It's something people are starting to look at. And because, as you've raised the point, people are concerned about energy usage. And the other thing as well is when you're transmitting huge amounts of data, there's a latency in it. It doesn't happen straight away. If it's interrupted or whatever, if it's critical, it's not good. I think what is happening now is people are going away from cloud connectivity so much and talking about edge computing. So do as much of the compute local to what you're doing and don't transmit that data, just transmit the data that needs to be transmitted. And that's definitely happening.
If the thought of all those data centers using energy keeps you awake at night, Bob, start worrying about Bitcoin mining. That's where they really start chewing up the energy. Barry, good evening.
Hi, and Ian, good to see you again. There's a reoccurring theme. I think the last time I saw you was eating a meal in the Midlands somewhere as well.
It was,
so,
yes.
You're in the Midlands and meals get about, don't they? Listen, I want to move it slightly and go back to probably a reoccurring topic of skills shortage, because it's all fantastic AI, but I remember reading an article, and it'll be a couple of years ago now, and it made me think about retraining, because it said there was something like 40 jobs for every AI programmer, and in the US they're earning up to 400,000 a year. So it's great having this technology. Do we think we've got the skills to be able to, flush it through industry? Have we got that in the UK?
Okay, so I'm going to do a bit of a plug for XpertRule here. Is what we've talked about is a low-code, no-code environment. So what we're doing is we're developing a platform which is usable by engineers and manufacturers and doesn't need the software coders to involve in it. It's already in there. So basically what we're talking about is having a toolkit which engineers and manufacturers can take and use to deploy their own applications. And I think the more robust an AI application becomes, the more it can be taken into that environment. And this is where I sort of talk about the difference between data scientists and domain experts. So it's probably finding the right technologies that work in those ways and are deployable. What you've got to remember is some of the AI where these people are working is using huge, it's using terabytes of data, and the sophistication in needing to managing those is very, very different. And a lot of them are literally massive algorithms that are working in a black box environment. We don't want that. We want something that's transparent in our sector. We need to understand it and see how it works.
And
so I think,
how about, what about the architecture of that though? Is it you're saying you're doing a plug for you and it sounds fantastic, it does, but are we going to get to this open architecture point at some point in the future where we're going to plug AI into AI? Is that going to happen? And
well, in theory, AI will feed into, so if you've got something around a manufacturing process, that AI will plug into an MES, an ERP, a PLM system, something else, it'll plug into it. So it basically has an API to connect to that. And if you've got AI working in another system, there should be an API that will connect that into that central system. So typically a PLM would be the repository for all the different bits of AI data from different sectors.
Okay, I'd like to move on. Steve, you had a question after Barry.
Is that me? Yeah.
Yeah.
Just one point I find a bit suspicious, not suspicious, but concerned with, Ian, and that is you're concerned with generating huge data lakes, and that your way around this is by focusing on what you calculate to be the key inputs. Yeah. Well, having worked in semiconductor manufacturing for like 40 years on and off, where it's absolutely key that you understand the key inputs. Even within that industry, very few organizations have really got a grip of grasping the key inputs. So what I'm sort of suspicious of is what fraction of our marketing or other sorts of organizations really will guarantee or work hard to get those key inputs, and what fraction will just sort of thrash about generating data lakes. And in other words, the net impact of AI is in fact orders of magnitude less than promised.
Okay, so this really then, so this comes back a little bit to how you create the process that manufactures something in the first place. So you actually go outside AI and start to look here at process simulation and process design and how you do that. So AI can only work on things that exist. It can't work on, it can only work on what's in it. So for example, if you take a semiconductor manufacturing line, it can take the data off that line and interpret that data against key outcomes, but using a domain expert. But the way a lot of people are working now is to use design software to design a process and simulate that process, then to use the data that's coming from the real process to start to refine that. So that's the only way I see you do it. So there's the software out there that there's companies like PSE, Perceptive Engineering, MATLAB, all doing these type of softwares that help you with the process design and the input output on the process.
Okay, we've got some more questions.
You still haven't answered the question about human nature, and maybe it's a bit like Barry says. Maybe it's a shortage of people with the expertise to do that.
The human nature, sure, I would have thought would be the domain expertise. It would be somebody who understands what is happening within that process.
That's another skill shortage, but we'll move on.
Okay, Mark Amphlett, I think you were next with a question.
Yeah, thanks. A couple of points. Awesome stuff again there as well. Really enjoyed that, Ian. I think we've alluded to it at the moment, garbage in equals garbage out. So how is it if just a little bit of information comes in which isn't quite right? Can that really escalate out and then really affect what happens in the future? So that's my first question. The second one is as well, you mentioned that AI has no emotions. Does that mean my wife has been programmed with AI?
Well, I can answer the second one. If my experience counts it, yes, same as mine. No. So yeah, the first one, it depends what the error is in that data. So it comes down to, basically AI is using statistics to look at data and how it works. If there's a strong correlation that's still valid, even though the numbers aren't quite right, it can be refined and trained to do it. If the numbers are totally wrong and the relationship's wrong, it's wrong. So normally what we say to people is ensure that the process is working as well as it can work and it's doing what it's sort of described to do and it's designed to do. If it's doing that, but it's not running under optimized conditions, we can run optimization loops on it and we can look at how those affect it to improve it. But if it's, if something's, say, like a motor's idling with maximum amps and you've only got 1 amp to run the process with, it will make no sense whatsoever.
I guess there's still some testing and measuring involved at this point, yeah?
Yeah, and validation.
Okay, perfect. Thanks, Ian.
Ewan, good evening.
Oh, good evening. Yeah, good evening, Nick, and good evening, Ian, and hello, everyone else. Just a couple of observations, really. I don't know if anyone else has read Tim Harford's book, How to Make the World Add Up. Trying to put it in the screen there, yeah. He writes for the Financial Times, and he's the undercover economist as well. And it's a really interesting, it looks at everything from a numerical perspective. And the reason for mentioning that is there's a chapter in here which talks about, algorithms and the importance of big data. And, we talk about open source versus closed source and think about companies like Google, who basically have built their business model on being a closed book. I suppose one of the observations really is that we get bought in, or we buy into this, we've done so much, analysis, we've looked at so much data, and it's given us this particular answer. So Google Flu Trends was a department set up by Google, and they would anticipate when there were going to be flu epidemics in North America a week or 2 weeks prior to them actually happening, based on when people were searching what they were putting into search engines. And this was wonderful for 5 years until they actually realized that it gave a completely erroneous result because of the way the search engine was in effect set up and the way the algorithms have been built. A bit like, we've seen it, I think, with photos when it identifies, because in effect the algorithmic code was, let's say, built by or designed by computer programmers who were white, based out of Palo Alto. Therefore they were looking for particular pixels relating to different photos. and therefore getting to the point where if they saw a black face or a different coloured face, then it would actually create the wrong outcome and drive a different set of conclusions to actually what you or I, or let's say a process engineer or an intelligent person with some knowledge would be able to come to. So I suppose I'm really making the point that, I still think there is an element of human sanity almost required, because we can't just rely on, and it's back to sort of, it ties in with the garbage in, garbage out point. And it also sort of just, to me, means that we still need to have somebody to apply common sense or sense check what we're talking about. And, otherwise this becomes just a big industry, and the big industry sort of gathers, momentum and critical mass. And we're all left going, well, hold on a moment, we've just paid a fortune to come up with that answer, which I already knew because I've got 35 years worth of experience. So there's a difference to me between trying to take what's in here and replicating it, and we're basically trying to replace what's in here. That's what I'm trying to say.
Yeah, I think you're absolutely spot on. I said a few times during the presentation, don't forget the human. To me, what you're creating is tools that help the human. So, for example, if you give a human a job to do where he's doing a repetitive task over and over and over again, he gets bored, he's going to make a mistake. Can automation improve that, and can you get away from that? And then can the human do the task which the human enjoys much, much better? So an example is companies get millions of emails a day. You can use AI and RPA to sort those emails and send it to the right person. If you haven't got that person doing that, and this thing lands on a person's desk, he spends all day doing sorting of emails, and he's not earning any money. So it's finding the right solution for it. But again, I wouldn't like closed loop autonomous systems. I think there was an issue there.
Okay, we're running slightly out of time, and I know there are more questions. Lee, and then Niraj, and I want to leave a couple of minutes. Angela, do you want a couple of minutes at the end? Yep, good. Okay, so Lee, and then Niraj, please.
Many thanks. More of an observation, really. The human race are unbelievably stupid and unbelievably intelligent, and everywhere in between. And my experience of AI, and I'm referring to my vehicles of assisted driving and things like that, they don't take into account the single bollard that's 6 inches out of the way, and when you're in cruise control at 80 miles an hour, and it picks it up and it stands on the anchors immediately, and you potentially cause an accident. But the point I'm trying to make here is everybody's afraid of AI. Just throughout history, people have been afraid of change. And what I've seen is a gradual steps. And everybody that's made a comment has got a valid point, and it all boils down to common sense. We need the domain that you were talking about. So the experienced human being with the knowledge. Unfortunately, those skills and those real world skills, people are retiring. So we need to educate the young, bring it up. We need apprenticeships. We need a training. We need more help with schools and education. But we were afraid of when the looms were made and the weaving industry and the cottage industry went back. So progression. Now, it's not going to be full AI in Ian's lifetime or my lifetime, but I'm sure it's going to be 25 steps ahead. We're going to have flying taxis. We're going to have Hyperloop technology. We're going to have AI, and it all boils down to data. And I was involved with a company called Cloud NC that basically want to take a CAM model, put it into a machine, press go, and do subtractive machining. And I challenged the CEO outright, so many variables that you can't take into consideration. Until they get all those variables logged as data, it can't be had. It's going to take up terabytes and terabytes, whatever, gazillion bytes. It will get there, though. And the human interaction will develop, and it will be, our economies will be based on lifestyle as opposed to we will all have jobs around chilling out effectively, and we will be down to 1 day a week work time in 500 years time. It's just a progressive steps, and it's not going to be here, and it all boils down to data, and the knowledge of that domain at the very beginning is key to AI working across all aspects of manufacturing. Thanks very much, guys.
Thank you. Brave New World from Lee Howarth there. Niraj, you had an observation question.
So what Lee said, but most of it, he's already said what I wanted to say. But the thing
Don't
is,
you hate that?
No, he hits the nail on the head, every time. And my point was regarding skill sets, what Barry talked about. The thing is, we should not have some very lofty expectations from AI in the work that we do or the businesses we run, because we need to start small. We need to pick an area, and the skill sets what we need are the domain expertise of our work, of our business line. We don't need programming skills as to get inside those applications, because those applications, the AI component enables it to learn a lot of the stuff on its own. That is the data that is being fed. So next time onwards, it is making some of those decisions as a human would do. So I don't think we should get bogged down by the problem of skill sets. It is about the mindset, and let us make a small beginning.
I question Iain, just to sort of wrap up. I think what I heard you say, if I'm trying to interpret what you're saying, is that what you're trying to do is democratize AI a bit by making this low code, no code interface, which means that we don't all have to be Tim Harford's mega number crunchers. We can just be people doing the jobs we do, and we can access the power of this stuff without having to know how or why it's working.
Effectively, yes, that's it. It's a tool to enable you to do your job better and create a better environment for it.
Yeah.
And the thing that AI can do, which we can't do, is it can look at very small changes very accurately. So if things are drifting and changing, it can pick them up a lot quicker than we can, just because of the nature of the beast. But yeah, the idea is, for me, if you think of vertical applications of AI, they need domain expertise and the knowledge, and it should be able to be used by those people.
Okay. Well, listen, I'm just going to take a couple of minutes because I want to hand over to Angela. For those of you who weren't here, Alison, put your camera on. Alison,
Sorry,
there, over there in Atlanta, Georgia, made a very inspiring presentation a few weeks ago about the virtual intern network that she developed when the pandemic knocked all her planned sort of apprenticeship and in-person kind of training for six. And so inspirational that Angela and Bob and Adam, who's actually had to go to another meeting, are trying to set something up themselves along those lines in the UK. Angela, you have a question to ask of the assembled.
Yes, so, all thanks to Alison for the inspiration for us to try and do this. Again, to try and get out into the schools and colleges. But what we really need some information from you guys so that we can look at what key challenges are, etc. Without that information, we can't sort of push it much further forward because we don't know all the answers. It's you guys that we need the answers from. So please, could I ask that you just take part in our fact finder? I'm just going to put the link in now. It's completely anonymous. There is only one question at the end that is optional, where you can, if you're interested in getting more involved, you can put your name and email address. You don't have to answer that question. So, fill it in. Don't answer the final question. It's completely anonymous. Fill it in, answer the final question. Then obviously we can get back to you if you're interested in getting involved. But it would be really good to get some response and get more people interested in what we're trying to do.
Oh,
Thanks,
that's
Nick.
brilliant, Angela. Well done. Well done. And if you're not able to lift it off the chat box, I sent another one email last night, which has the same link in it. So if you're not able to pick up the link from the chat box, just go back to your inbox from about, I don't know, what time is it, Angela? About 5 o'clock last night. A second of my emails to you. Iain Crosley, thank you so much for being with us. It's so wonderful to see you again. And I'd also like just to say, Johnny Williamson, raise your hand. I haven't seen Johnny for donkey's years. My dear old colleague from the manufacturer. And it's wonderful to see you here. And he wrote a great article about AE Aerospace, which had a lot to do about 5G in it. We haven't got time to talk about that tonight, but maybe Johnny can come back and maybe get Peter Brook to come along and have a chat as well, because he seemed an amazing guy. Iain, again, thank you, and come back. You know, this is you know, once you're here, you're doomed. You're here for life, man. It's a life sentence. You get less for murder. Bless you, everybody. Happy Easter. Have a wonderful long break, wonderful long weekend. Next week, I'm going to be in the not only in the chair, I'm also going to be presenting something. So I'll look forward to talking to you all then. In the meantime, have a wonderful week, a wonderful weekend. Thank you for being with us. It's mailback time. I'm out of here. Take care.
Each and everyone. Bye-bye.
Bye, everybody.
Bye-bye.